This is section 4.9, and we're talking about going to graph quadratic inequalities now. We've been graphing quadratic equations. Now we're going to graph quadratic inequalities. Now, to graph quadratic inequalities, we're essentially, it's not going to be anything different. You're going to graph the parabola the same as we have in the past. Again, if it's in standard form, we got to find the vertex and then use the y-intercept. If it's in vertex form, we find the vertex, we do the 2 points to the right of it, reflect it, so forth and so on. So that process is not going to be any different. The only thing that's going to be different here is this information down here, which in this case, again, if it is greater than or less than or greater than, it's a dashed curve. So if there's not a line underneath, it's going to be a dashed curve. And if there is a line underneath, less than or equal to or greater than or equal to, it's going to be a solid curve. Okay. If it's less than or equal to, we're going to shade below the curve. And if it's greater than or equal to, it's going to shade above the curve. Okay. Now, the one thing that we're going to do a little bit differently here as well is we're going to check to make sure that your shading is correct. You can always pick a test point and see if it works. Okay, and you'll see me do that in one of our examples. Okay, so let's take a look at some of our examples now. Okay, and we'll take a look here at this first example. Got to find some information first here. So we've got y is less than negative x squared minus 9x minus 2, and we recognize that this is in standard form. Okay, so as we recognize that this is in standard form, I've got to figure out, first of all, I've got my a is negative 1, my b is negative 9, and my c is negative 2. Okay, so I got to find the vertex, my vertex. I got to find the opposite of b, which in this case the x value, the opposite of b is 9 over 2 times a is negative 1. So this is going to be 9 over negative 2, which I'm going to go ahead and make that a decimal, which is negative 4.5. So the x value of my vertex is negative 4.5. Okay, and now I'm going to take that negative 4.5 and plug it in. So I've got the opposite of negative 4.5 squared minus 9 times negative 4.5 minus 2. Okay, negative 4.5 squared is 20.25, so I've got negative 20.25, and negative 9 times negative 4.5 is positive 40.5, and minus 2. So now my y value, if I combine all those like terms, I end up with the number 18.25. So the y value of my vertex is 18.25. Okay, so I've got the vertex. The vertex is the key part. I also need the y-intercept, and the y-intercept in this case is the ordered pair 0 and c, and which is 0 and negative 2. Okay, so I'm going to plot those 2 points. Now you'll notice as you look at your graph, okay, your graph doesn't go all the way up to 18. So I'm going to end up going by 2's here. Okay, so as I count by 2's, I'm going to plot my vertex, which is left 4.5. So it's going to be left 2, left 4.5. Okay, and then I'm going to go up 18.25. So this is 2, 4, 6, 8, 10, 12, 14, 16, 18. And then 0.25 is going to be a little bit past that line. Now, obviously, it's not going to be exactly perfect. Okay, but I can zoom in on that mark, and I can put it in there. Now the nice thing is on your apps you're going to be able to do that. Okay, so I'm going to go left 4.5 and up 18.25, which is going to be right about in here. Okay, so that's my vertex. My y-intercept is 0 and negative 2, right there. Okay, now, the key to doing the reflection here is to calculate how far is it from that point to the y-axis. Well, this is 4.5 units. Okay, so if I count another 4.5 units to the left of that guy, okay, if I count another 4.5 units to the left, you'll notice, again, it should be at 9. So 1, 2, 3, 4, 5, 6, 7, 8, and 9, which would end up being way out here. No, take that back. Wouldn't be way out there. Why wouldn't it be way out there? Because we are going by 2s, so 2, 4, 6, 8, and 9 would be right about in here. Oh, wrong spot. Having all kinds of trouble today. Right about in here. Okay, so now I've got my points, and I can now, as you look, now let's take a look at the example here up top, and let's see. As you look at this guy means we're going to, it's going to be a dashed line, and we're going to shade below the curve. Okay, so I go back, I'm going to draw a dashed curve to the best that I can. Okay, my curve is going to be dashed like so. Okay, and I'm going to shade below it. So I'm going to shade below the vertex, so I'm just going to color this guy in like so with lines. And you're done. Okay, now that was a pretty complicated one. That was a pretty tough numbers-wise one. Okay, let's take a look at the other example here. This one isn't near as complicated, but it is kind of interesting. Okay, so let's take a look here at this one as we look at this second one. Okay, now again, I got to identify it's in standard form, so I've got A is 1, B is 0, there's no B there, and C is -2. So I've got to find the vertex. The vertex, the opposite of B, so the opposite of 0, which is just 0, over 2 times 1, this is just going to be 0. So the x value of the vertex is 0. If I plug 0 in, I get 0 squared minus 2. 0 squared is 0, so I end up with -2. Now, the y-intercept happens to be the ordered pairs 0 and C, which C is -2, but you'll notice that your y-intercept and your vertex are exactly the same. Okay? So in this case, when your vertex and your y-intercept are exactly the same, we've got to choose another point. So I'm going to go ahead and plot the point 0, -2 down here. There's 0, -2. I'm going to pick a point to the right. The first point to the right of 0 is 1. So now I'm going to plug in 1. So if I plug in 1, I get 1 squared minus 2. Okay, so the ordered pair I'm looking for, the x value is 1. 1 squared is 1, minus 2 is -1. So now I'm going to plot this ordered pair. Right 1 and down 1, and then I'm going to reflect that. Okay, so I reflect it across, and now I can figure out what I'm going to draw. Again, this guy right here tells me that I'm going to draw a dashed curve. Okay, so I got a dashed curve, and it also says that I shade above the vertex or above the curve, so I'm going to shade above the vertex, like so, and you're done. So in this case, whenever you have a y-intercept and your vertex are the same, you've got to find one more point. Okay, let's look at this final example now. Okay, again, it's in standard form. I'm going to graph it, so I've got to find the vertex here. I've got the opposite of B is 6 over 2 times A is -3. This is going to be 6 over -6, which is -1. Okay, x value of the vertex is -1. If I put -1 in, so I've got -3 times -1 squared minus 6 times -1 plus 1. -1 squared is 1. Times -3 is -3. This is going to be plus 6. -6 times -1 is positive 6. And plus 1. Minus 3 plus 6 is 3. Plus 1 is 4. So my vertex is the ordered pair 1, 4. -1, 4. The y-intercept is the ordered pair 0 and C, which is 1. And now I'm going to plot. Now, the one thing I am going to change on this, make sure you change this on your sheet. I'm going to put a line underneath this guy so you guys can kind of understand what greater than or equal to will look like. Okay, just so you see the difference. Let's take a look at, and let's graph these now. Okay, so my vertex is at -1, 4. left 1, and up 4, put a dot. My y-intercept is 0, 1. Okay? Reflected across, it's 1 away, so I reflect it across like so. And I'm going to draw a solid or dashed from this line right here. This is going to be a solid because I changed it, because it's greater than or equal to. And we're also going to shade above the vertex. Okay? So, I draw my solid curve here like so. And I'm going to shade above the vertex, so I'm going to shade above it, which is out here. Okay? Alright, so you've now learned how to graph quadratic inequalities. Again, not a lot different than regular inequalities, other than you're going to either shade above or below, and you're going to have either a solid or a dashed curve. Okay, this concludes section 4.9, graphing quadratic inequalities.